This video is going to cover section 8.4, which is going to look at nonlinear functions. As we review, a domain is all possible x values, and for most functions, that's negative infinity to infinity. For example, if it's a line, it's going to go forever on the right, forever on the left, negative infinity to infinity. A square root can never have zero, or can never have a negative number under the radical. So we would say t minus 1, which is what's in the radical, has to be greater than or equal to 0. Add 1 to both sides, and we get t is greater than or equal to 1. To write that in interval notation, we would say it starts at 1 and goes up to infinity. For rational functions, where the fraction's on the bottom, you can't have 0 on the bottom of a fraction, so v plus 3 cannot equal 0. If you subtract 3 from both sides, you get v cannot equal negative 3. So the domain would be negative infinity to negative 3, and then negative 3 to parentheses, or to infinity. And we're using parentheses because it can't actually touch negative 3. Let's look at one graph. We have absolute value. Absolute value is the distance from 0, so it's always positive. No matter what's inside, the outcome is positive. So if you have absolute value of negative 11 is 11, absolute value of 4 is 4. The graph is over here, it's the v. So our domain is negative infinity to infinity, because it goes in both directions forever. And then our range, this is the smallest it ever gets, because it has to be positive. So our range is from 0 to infinity. Infinity, there we go. Polynomials are multi-term equations or expressions that have a degree. Degree is your highest exponent. There are no negative exponents in a polynomial, no variables as exponents in a polynomial, and they're not rational. Rational functions are not polynomials. We can name these functions by their exponents. If the highest degree or the highest exponent is 1, it's linear. If the highest exponent is 2, it's quadratic. If the highest exponent is 3, it's cubic. So let's look at some. F of x does not have a negative exponent, does not have a variable as an exponent, is not rational, so yes, it's a polynomial. The highest exponent is 3, so it's cubic. Let's look at g. We have a negative exponent, so already we know it's not a polynomial. It can still be a function, it's just not a polynomial. Looking at h, we have no negative exponents, no variable exponents. It's not rational. The highest degree is a 1 because it's not there. So this one is linear. And then j of x, we have x on the bottom, so it's rational, so it's not a polynomial. All right, now let's look a little more. Evaluate is just like every other evaluate we've talked about. You just plug that number in and solve the original polynomial. So here I would write negative 3 times 2 to the 4th minus 2. Exponents first, 2 to the 4th is 16. Multiplication, negative 3 times 16 is negative 48. And negative 48 minus 2 is negative 50. If we do the next one, we'd rewrite it, but instead of x, I'm going to put negative 3. Negative 3 cubed is negative 27. Negative 3 squared is 9. Negative 2 times negative 27 is positive 54. Negative 4 times 9 is negative 36. And if I put that all in a calculator, I'm going to get 23. So evaluate, plug it in, do the math to get the answer. All right, let's look at a real world problem. Let P of t equal this equation. That's going to model an athlete's heart rate in beats per minute after strenuous exercise from 0 to 8. That means we're only using this equation from the moment they stop exercising, 0, to 8 minutes after. Past that, this equation doesn't work anymore. So the initial heart rate, that's when time is 0. That's right when they stop exercising. If you plug 0 in for t, we're going to get 200. So right when they stop exercising, it's 200 beats per minute. What is the heart rate after 8 minutes? So now we're going to plug in 8 for the time, because that's how long we're talking. And if we plug that in the calculator. We get 48.8. Now we want to graph and interpret. So I want to put this equation in our y equals. So in our calculator, we're going to hit y equals. We're going to type that equation in y1. Now for our window, we're going to use the numbers they give us. So we're going to say 0 to 8 for our x, because those are the times they tell us to use. And then our y minimum's 48, so I'm going to say 40. And our max is 200, so let's just say like 210, so we can kind of see what happens above that. Then we hit graph. Now we have our line. Ignore those dots. So that curve goes down. So as time goes on, the heart slows. And the beats per minute get lower. It looks a little bit steeper at first and then kind of flattens out. Lots of different ways you can explain, but interpret, you're just kind of talking about the graph. All right. As I mentioned before, rational functions are not polynomials. They have what's called an asymptote. It's a line that the graph approaches, but never crosses. Approaches, but doesn't cross. It means that the graph is undefined at that value. So it's when the denominator equals 0. So if you find the interval, if you find the domain, you're automatically finding that vertical asymptote. So 1 over x plus 2. To find the domain, we have to say x plus 2 cannot equal 0. So we subtract 2 from both sides. We get x cannot equal negative 2. So the domain is negative infinity to negative 2, negative 2 to infinity. And this is going to be our vertical asymptote, which I'll mark as VA. So if we were to graph this, it would look something like this, meaning it's going to get closer and closer to that pink line, which should actually be at negative 2. So it happens when I sketch instead of actually pay attention. So g of x here. First, we're going to tic-tac-toe the bottom. So 1, negative 3, 2, negative 2, negative 1. So our bottom is really x minus 2, x minus 1. If we make each of those equal 0, one of our asymptotes is 2. Another asymptote is 1. And then our domain would be negative infinity to the smaller asymptote. And then from one asymptote to the other. And then from the bigger one to infinity. So you're always going to have one extra parentheses than the asymptotes. All right, this last one. T cubed minus 3 cannot equal 0. So if I add 3 to both sides, we get t cubed can't equal 3. Take the cubed root to get the t alone, and t cannot equal the cubed root of 3. So our vertical asymptote would be t equals cubed root of 3, and our domain would be negative infinity to cubed root of 3 and cubed root of 3 to infinity. You can also graph these on a graphing calculator. Type them just like we would any other thing, but we want to have the top and the bottom separate. So 1 divided by x. If you hit zoom 6, that's going to take you into a standard 10 by 10 grid. So that shows us that this first graph looks like this. If we graph the second one, we want to put the top in parentheses and the bottom in parentheses, because your calculator will do order of operations, so it'll mess things up. That one looks like this. Now, here's our vertical asymptote. Here's our vertical asymptote. On this one, it would be 0. And on this one, we'd add 1 to both sides, and we get x equals 1. That's how those vertical asymptote works. That's where that break is in the pieces. All right, let's use those same f and g and evaluate a couple equations. So we've talked about a bunch of things. Try pausing the video and see if you can evaluate f and g for those numbers down there. All right, so f, I'm going to do in red, and plug negative 1 in for x. So 1 over negative 1 is negative 1. plug 1 in for x. 1 over 1 is 1. Plug 2 in for x, we get 1/2. If I evaluate g of -1, it would be 2 times -1 over -1 minus 1. 2 times -1 is -2. -1 minus -1 is -2. And if we divide those, we get +1. We do g of 1. 2 times 1 is 2. And 1 minus 1 is 0. We can't have 0 on the bottom, so it's undefined. I like to write this little null set thing. And then g of 2, we would do 2 times 2 over 2 minus 1. 2 times 2 is 4. 2 minus 1 is 1, so we would get 4. If you end up doing a profit equation, remember cost, they're going to give you information. That's what you spend to create whatever. Revenue is what comes in. The profit is when you subtract those. So once you make the two equations, you can combine like terms, and then you have a profit equation. Function notation is when we write like f of x and g of x. So I can just say f or g, and you can know exactly which one we're talking about. There's different ways you can combine them. So if you see something like this, where it says f plus g of x, that's saying take f of x, take g of x, add it together. It also might look like this. So the f plus g could be in parentheses, or it could be separate. Minus works similarly. So does multiplication, and so does division. Division just has 3 choices because of the fraction. So whatever you see, it's just telling you to do that with the 2 functions. So let's look at this first one. It says f plus g of 3. So we're going to take f of x and plug 3 in. So f of 3 is 3 squared, which equals 9. G of 3 is 2 times 3 minus 4. So 6 minus 4 is 2. And then we add those together. So 9 plus 2 is 11. This one says multiply. So first we find f of -1, which is -1 squared, or 1. And then we find g of -1, which is 2 times -1 minus 4, which would be -2 minus 4, which would be -6. And then we multiply them together. So 1 times -6 is -6. This one says f divided by g of 0. So f of 0 is 0 squared, which is 0. G of 0 is 2 times 0 minus 4, which is 0 minus 4, which is -4. And then we do 0 over -4, which is 0. Then let's try f divided by g of 2. F of 2 is 2 squared, which is 4. G of 2 is 2 times 2 minus 4, which is 4 minus 4, which is 0. So then we have 4 divided by 0, which we can't do, so there's no solution. So if you have a number, you're just plugging it in and then solving. If you don't have a number, like all of these just have x, we're going to take the equations as is and combine them. So this first one, f of x plus g of x, I'm literally going to write f of x. I'm going to write g of x, and then I'm going to add them together, which is combining like terms. So 4x plus 3x is 7x. -5 plus 1 is -4. And that's as simplified as I can get it, because nothing else reduces or cancels or combines. Next one, f over g. So we would write f on top of a fraction, g on the bottom. There's nothing that needs to be factored and nothing that cancels, so that's our answer. Now let's do f minus g. So f is 4x minus 5, and then 3x plus 1, and we're subtracting. The big thing to pay attention to is we're subtracting the whole function, so we're going to need to distribute that negative sign. So it's really 4x minus 5 minus 3x minus 1. Now we combine like terms. 4x minus 3 is x, and -5 minus 1 is -6. And then the last one here is f times g. So when we have 2 binomials, we can FOIL. First times first gives us 12x squared. Outside times outside. Inside times inside. And last times last. Then we combine our x terms, and we get this trinomial. That is 8.4. Let me know if you have any questions.